So, hi sir, good day. I am the Cadet Lopez and we are the Group 8 and we are here to report about the compass error. So first, the learning outcome. At the end of the lesson, the students should be able to answer the following questions. So first is, how do you calculate compass error? Then, second, what causes compass turning error? Then third, what are the errors associated with a magnetic compass? And fourth, what are the methods of determining the errors of gyro compass? Then last is, what would have happened as a result of compass failure? So, why do we need to take compass error? So, the compass error should be checked each watch and on every new course to measure the error of the gyro compass, which is the angle of the gyro north makes the true north to establish trends in deviation on different courses at varying latitude. So, this is important because should the gyro compass fail, this information will be needed to set courses using the magnetic compass. Next is the definition of compass error. So, compass error is the algebraic sum of variation and deviation. It is the difference between the true north and compass north. Next is the method to calculate the error. So, by transit, you have to look for the nearest fixed two targets from the chart in your location and take its bearing in a vertical line from the chart. Record and put your vessel's heading in the same line to become you in the same line with both, and when transit them recorded your course from gyro compass and compare with the true bearing on the chart you had been already registered. Then, that's difference between two reading is the value of the error. Keep in your mind the calculation of the variation. And the second way, when you on the pier alongside the jetty, you can get the bearing of the jetty from the port chart and compare it with your reading compass in the same position regard. Then here's the example as what you can see in the screen. So deviation is equals to 1.5 east and the variation is 5.0 west. So you must add the deviation and variation. So negative 1.5 plus 5.0 is equals to 3.5. So the compass error is 3.5 west. So figuring out the compass error, your ship is steering course 0542 and 060 PSC. The PSC is for standard compass. So what is the compass error? 60 minus 54 is equals to 6, but it is west or east. So, since true heading is the west of compass heading, the angle of compass error will be labeled west. In order for the gyro compass to read what the true heading of the vessel is, the needle would have to be pointing a little to the west of where it is pointing now. So, remember the saying, compass is best, error is west. So, compass is east, error is east, or true less west. Once we have the compass error and the variation can be found on the chart, we can now determine the deviation for the vessel on that heading. Then, as what you can see in the screen, nahanap po tayo ang example. So, true heading is 054 and the compass heading is 060 and the compass error is 6 west. So we can find that the variation for the area is 4 west. And what is the deviation? So you must subtract the compass error and the variation. 6 west minus 4 west is equals to 2 west. This is just the opposite of how we found the compass error when we know the variation and deviation. The next reporter is Mata.
Different methods of finding compass error. By azimuth of a celestial body, this has been discussed in detail in a separate module. Sun, selected stars, moon, and planets can be used. By amplitude of a celestial body, Usually, the sun or moon is for taking amplitude, which is explained in detail in a separate module. The amplitude is taken when the body is on the true horizon. Stars and planets, being small and dim, when are on the horizon, are not suitable. When at birth, the difference between the observed direction of the jetty and the charted direction when the ship is fully alongside will give the compass error. Caution: this will only be accurate if the vessel is close to the jetty throughout its length and the jetty extends to the full length of the vessel. This may not be accurate if either the bow or stern is away from the jetty or the jetty is not complete. In some ports, the ship may never be alongside the berth due to various reasons, and hence, this method of taking an error should be double-checked as soon as possible after departure by either taking an azimuth of a celestial body or by taking a transit bearing. Transit bearings: this is a line on the chart where an observer would see two identifiable objects in line. A bearing taken when both the objects are in line can be used to determine the gyro and compass errors by comparing charted and observed bearings. Leading lights: this is similar to transit bearings where two identifiable objects are used to draw a line or bearing on the chart. These bearing lines are used to indicate track to be followed when approaching a port or a channel. The difference between the charted bearing and the heading of the ship when on the leads can be used to determine the error on both gyro and magnetic compass. Beware of parallax error with this method. Spring-mounted bows and cards of extremely small diameter elevated the problem, but tilting still occurred, bringing the system frequently under influence of the vertical component of the Earth's magnetic field and causing erroneous readings. The most important of such effects, called northerly turning error, caused the compass to indicate a greater or smaller angle than was actually being turned through. Other problems were the difficulty of obtaining stable magnetic conditions in the cockpit, with its array of metal and electrical equipment, and the need for the compass reading to be fed to other navigational aids. In the end, the direct reading magnetic compass was reduced to a secondary role, its place being taken for most purposes by the gyromagnetic compass. Magnetic compass errors. The magnetic compass is the simplest instrument in the panel, but it is subject to several errors to consider. The acronym VDMONA or VDMONA helps pilots remember compass errors. Variation. The true North Pole and the magnetic North Pole are not located at the same spot. This variation causes a magnetic compass needle to point more or less away from the true north. The amount the needle is offset is called variation because the amount varies at different points on Earth's surface. Even in the same locality, variation usually does not remain constant, but increases or decreases at a certain known rate annually. The variation for any given locality, together with the amount of annual increase or decrease, is shown on the compass rows of the chart for the particular locality. Division. The amount of magnetic compass needle is deflected by magnetic material in the ship is called deviation. Although deviation remains a constant for any given compass heading, it is not the same on all headings. Deviation gradually increases, decreases, increases, and decreases again as the ship goes through an entire 360 of
acceleration and deceleration error. When on an east or west heading, any increase in airspeed or what we call acceleration will cause the magnetic compass to indicate a false turn toward the north, and any decrease in airspeed or deceleration will cause the magnetic compass to indicate a false turn toward the south. Oscillation error. This error is caused by turbulence and rough control movements and results in erratic movement of the compass card. Oscillation is a combination of all of the other errors. and it results in the compass card swinging back and forth around the heading being flown. Magnetic dip error is the tendency of the compass needles to point down as well as to the magnetic pole. Dip is the greatest near the poles and least near the magnetic equator. The compass card is designed to operate in the horizontal, therefore any movement from the horizontal plane introduces dip error. The needle of your magnetic compass will be parallel with Earth's surface at the magnetic equator, but will point increasing downward as it is moved closer to the magnetic pole. Northerly turning error is due to the mounting of the compass. Since the card is balanced in fluid, when the aircraft turns, the card is also banked as a result of centrifugal force. When the card is banked, the vertical component of the Earth's magnetic field causes the north-seeking ends of the compass to dip to the low side of the turn. When making a turn from a northerly heading, the compass briefly gives an indication of a turn in the opposite direction. When making a turn from the south, it gives an indication of a turn in the correct direction, but at a faster rate. What would have happened as a result of compass failure? It will surely cause major accidents, and gyro compass is a mechanical device. With time they tend to fail. If such failure happens during navigation, pilotage, entering or leaving a port, or in TSS, then steps to be taken to avoid incidents must be followed. So this will be the following steps. Actions to be taken in case of gyro failure. First is to inform the master. Then switch over to second gyro compass if fitted. Change over to manual steering with magnetic compass by applying the last calculated compass deviation value with deviation curve and observation. Then calculate the course to steer by magnetic compass by taking into account the deviation last calculated and the variation from the chart. Next is to plot positions frequently to confirm course made good and accordingly allow correction to course steered. Then in coastal waters, make good use of parallel indexing techniques to keep the vessel on chart track. Also secure the course made good CMG by plotting GPS position and verify it with the heading of the magnetic compass. As there is gyro failure in progress, consider the effect on the other navigational and communication equipment with gyro heading. Feed like radar, ARPA, and ECDIS and enter headings manually. The radial will automatically switch to heads-up mode. Switch on both the steering motors. Notify the engineer on watch about the gyro failure and reduce speed or standby by engine if considered necessary. If in the high-density traffic area, then as per master's instructions, inform the nearby traffic. If required, change the bridge watch level to a higher level. Input manual heading in ECDIS. If only one gyro is fitted and if the second gyro fitted, change the feed to the second gyro. Record the time in GMT and LT of gyro failure on the course recorded chart. Inform pilots at the next port about gyro compass unavailability. Note down the cause of failure in deck logbook if known. Later investigate the cause and master to inform the company. In the meantime, check the instruction manual for troubleshooting guide if possible. So that would be all our report. Thank you for listening.